Okay, so this is the question 3 in your numerical examples tutorial sheet. So this figure 2 shows the so-called the sexy modification of a simple engine mechanism, which is aimed at reducing the side thrust on the cylinder wall during the firing stroke. So working from the first principle, show that the acceleration of the piston is given by this equation here. And in this case, as you see, there is the piston is along this line here, but the crankshaft is the O point, or the center of the crankshaft is this point here, and then the distance here is given, which is E. And then the crank radius is 80 millimeter, and it rotate it this revolution per minute. The length of the connecting rod is 250 millimeter, and the offset is 20 millimeter. When theta is equal to 110 degrees, the pressure acting on the piston of diameter is 10 centimeter is 3 bar above the atmospheric, and the piston has a mass of 1 kilogram. So determine the forces between the piston cylinder, the forces at the main bearing, and the torque, and clearly indicate the direction of the forces and the torque, and neglect friction, gravity, and the mass of the connecting rod. Okay, so in this case, first we in part A, what we need to calculate is to prove this equation here from the first principle. This means that we will start from the basic equation that we did in the previous case. So as you're going to see in this case, x is the displacement, and from this specific case, x is equal to again r cos theta plus qr cos of phi here. So what we did in the previous case is that we will need to calculate this cos phi in term of in term of theta here. Okay, so now if we look at this diagram here, so if you look at this diagram here, the O point is here, and this distance is given, which is E, and this angle is theta here, and this is our R, and this is QR, and this is phi angle here. And now we can draw this thing here, and we can call this A, B, and C. So from the trigonometry, what we can see is that BC is, you can calculate from these two triangles. So BC is, if you look at this triangle here, so it will be QR into sine of pi. And if you look at this triangle here, so in this triangle you will calculate CA, and then you will subtract E here, which is this distance here. So what you can say is R cos R sine theta minus E. So R sine theta minus E is just this BC here. So from here you can calculate this thing here, and then from here we can calculate sine pi. So sine pi will become equal to sine theta divided by Q, and then minus E divided by QR. So if you just take this QR to this side here, so R will cancel with R, and here it will become QR. So sine pi become equal to sine theta divided by Q minus E divided by QR. But obviously we need to calculate cos pi, not sine pi. So we can just use the sine square pi plus cos square pi equal to 1. And from here we can calculate cos pi here. So which will become equal to 1 minus sine theta divided by Q minus E divided by QR whole square, and this become under root or power half, which is, so cos pi, we calculated cos pi here. This was our equation 1, and you can call this equation 2 here. So you can say that put equation 2 in equation 1. So if you do this, what you will get here, um, but before doing this, what we will do, that we will just need to simplify this equation here first. So we will not do this. First, we need to simplify this equation using the binomial equation here. And we know that the binomial equation is this here. So 1 plus x whole n, which is equal to 1 plus nx, and plus n minus 1 divided by 2 pictorial x square, and plus so on. So in this case, even we can take the first two and then can neglect the x square, because as we saw earlier, it's become a very small value, so we can ignore that part here. So if you just cos pi, because in this case n become 1 by 2, so it become 1 minus half, and x is minus sine theta divided by q minus e divided by q r square. This is our so it become minus half, and sine theta divided by q minus e divided by q r square, and plus so on. But we are ignoring the remaining terms here. So from here you can simplify this equation here, or now this is our equation 3 here, which is the simplified version of this equation 2. So now you can say that putting equation 3 in 1. So if you do this, x will become equal to r cos theta, and plus qr, and then in term of cos pi, you will just put this value here. So it's 1 minus half, and sine theta uh, divided by q, e divided by qr whole square. You get this value here, and now you can simplify this value, so it's become equal to r. You can take r common, and cos theta plus q, and then become equal to minus q by um, so it become this thing here. So this become our x, which is our equation 1. And now to calculate velocity, you need to differentiate this equation with respect to time, so which will be dx by dt here, and dx by dt is our x dot, or velocity. So if you differentiate this equation with respect to time here, so what you will get minus r omega, which is theta dot, and so I will just write the final equation. So sine theta plus sine 2 theta divided by 2q minus e cos theta divided by qr. You get this equation for the velocity. And now again, if you differentiate the velocity with respect to time, so this will become d square x divided by dt square, which is x double dot, and this will become minus omega square r, and this become cos theta plus cos 2 theta divided by q, plus E sine theta divided by QR. So this is the equation 3, which is the equation for the acceleration, and this equation is exactly the same as this equation here. So this means that the for this specific uh, engine, the equation for the x double dot, which is the acceleration, is this equation here, which we proved here, and which we derive from the first principle. So we start from the x, then uh, we calculate this cos pi using the binomial equation, and then from there, then we calculate the x, and then x dot, and then x double dot. We can solve the the second part, which is this part here. So the crank radius is given. So the crank radius is given, which is r, and which is 80 millimeter, and it rotate it omega, which is 1500 rpm. So obviously you will need to convert this into radian per second, so which will become 157.1 radian per second. And the length of the connecting rod is 250, so L is also given 250 mm. And the offset E is given, E is also given, which is 20 millimeter. And when angle is 110 degrees, so this angle is 120 degrees, the pressure acting on the piston of diameter 10 centimeter. So diameter of the piston is given, which is 10 centimeter here, and the pressure which is given is 3 bar. So bar is 10 power 5 Pascal. So this is a Pascal here. And the piston has mass of this. So mass of the piston is given, which is 1 kg. Determine the forces between the piston and cylinder. So you need to calculate F2 here. And the forces at the main bearing and the torque, so which is F1, is also unknown, and the torque is also unknown. And then you neglect all these quantities here. Okay, so now what we're gonna do here, we will just consider the piston here first. So on the piston, as you can see here, we have this force of the connecting rod, which is what we call is F1, and we have another force, which is this F2. So F2 is from the cylinder on the piston, and you have PA from here, and this angle is given, which is pi. Okay, so first thing is that pi is not known, so we need to calculate this pi here. So if we go to the original figure here, which is this figure here, so from this figure we can calculate phi from this equation here. So as you can see that sine pi is equal to sine theta divided by q minus E divided by QR, because everything is given. So we will just need to copy this equation, and you will just use this equation here. So this equation will give you uh, pi angle here. QR, okay, so pi angle will become equal to sine inverse. So sine 110, the angle is given 110, and q you can calculate from here. So q is equal to L divided by R. So 250 divided by 80. So from here you can calculate q, so which will become 3.125. So 3.125, and then minus 20 divided by q, so which is again 3.125 into R. So R is given, which is 80. So again, if you want to convert this to meter, so from here you can calculate pi, which will become 12.75 degrees here. So we calculated pi here. Okay, so now we can use the equilibrium equation. So first is that summation of all the forces in x direction equal to mx double dot. Okay, so this means that we need to calculate x double dot here, which is the acceleration when angle is when theta is equal to is 110 degrees. So we derive the equation for x double dot, which is this equation here. So it is minus omega square r cos theta plus cos 2 theta divided by q plus e sine theta divided by qr. So if you just put the values here, so minus omega square, so which is omega is 157.1 square into r is 80, so 0.08 here, and then in the bracket you have cos angle is 110 and plus cos, so 2 theta, so it become equal to 2 times 110, and q is 3.125, and plus e is again 0.02, and again sine 110, and divided by qr, so q is 3.125 and r is 0.08. Okay, so now from here we can calculate the value of this so 1011 meter per second square. So this is the acceleration when the angle is 110 degrees here. Okay, so now we can use this equation here. Summation of all the forces in x direction equal to mx double dot. So as you're going to see in this free body diagram here, the acceleration is obviously in this direction, and this is our x and this is our y. So in x direction, we have minus pa in the x direction, and then you have f1 plus f1 cos of phi equal to mx double dot. So this is the equation in the x direction. So in this case, as you can see, you have f1 here. So f1 you need to calculate, and cos of pi. So pi is given here, which is 12.75. We just calculated it here, degrees, and minus pa. So p is given, which is this value here. So 3 into 10 power 5, and you will need to multiply this with the cross section area of the piston, uh, which is pi by 4, and d square, so d of the piston is 10, so which is 10 centimeter, which is 0.1 square. So and then on the right hand side you have mass, so mass is 1 kilogram, and x double dot is 1011. So from here you can calculate the value of f1, which is going to be 3.452 kilonewton. So you will calculate this in Newton, and then you can convert into kilonewton here. And finally, we want to calculate the F2. So F2 is going to be when we will use summation of all the forces in y direction is equal to 0, because the body is not moving in the y direction. So in the y direction, you have F2 minus F1 sine pi equal to 0. So in here, the only unknown is F2, because we already know F1. So which is 3.452 sine of angle is given, which is 12.75. So then here you can calculate this value, which will become equal to 0.762 kilonewton. Okay, so this is the value of the F1 and F2, and the direction of these forces is exactly the same, because what we get here are positive. So this means that the directions are okay. Okay, finally we need to calculate the instantaneous torque here. So to calculate the instantaneous torque, we will need to draw the free body diagram for uh, so this was the free body diagram for the piston. Now we need to draw the free body diagram for the crank, and the angle is given, which is 110 degrees. So this was the piston, and then the angle here is given. The theta angle is one theta is 110 degrees here. So it will look like this. It 120 degrees, and now you can connect this point with this point here, and we know that the F1 was in this direction, and this angle was pi, and similarly F1 will also act here, and this is the center of the crank here. So again we will have another force, which will be in this direction here, and this is our angle, again is pi angle here, and again this force is equal to F1. So this is the OA is our position of the crank, and this is 80, which is given to us. Now we need to calculate this torque here. So we know that torque is force, which is F1 times the perpendicular distance. So if we draw a perpendicular from here, so this is the perpendicular that is on this line here. So, and if you call this, for example, C, so OC is the perpendicular distance that we need to calculate here. So we know already F1, but now we need to calculate OC, which we can calculate from the geometry here. So because we already know this OA is given, which is R, which is 80. So this distance is given, which is 80 here. Okay, so now now as you can draw a vertical line here. If you draw a vertical line, so this means that this vertical line is perpendicular to this line here, and then this line is perpendicular to this line here. So the angle between here is between these two lines is pi. So the angle between these two lines should also be pi here. This angle is also pi angle. Okay, so now because as you can see this angle, so this angle, as you can see here, is 90 degrees, and this total angle from here to here is 110. So then this means that 90, and then this will become 20 degrees. So this is the 20-degree angle here. Okay, so now what we need to calculate is that uh, we need to calculate this pi angle here. So if you want to calculate this OC, so OC is just If you consider this triangle here, if you consider this triangle OCA, triangle OCNA, if you consider this triangle, then this triangle OC is just equal to 80 into cos of, and the angle here is 20 plus 20 plus pi, and obviously we know this pi angle, which is 12.75, which you calculated earlier. So from here, then you can calculate the OC here. So now if you want to calculate T, so this will become equal to F1, which is 3.452 10 power 3, because it's kilonewton, and then you just multiply with this here. So if you convert this into meter, 0.08 cos of 20 plus 12, so it becomes 32.75 degrees. So this you will be able to calculate the instantaneous output torque here.